In this video, I will be explaining homework 5 question number 2. So question number 2 was first to draw the non-zero definition region of fxy. So we can see that fxy is defined as 1 by a into y square into x, where y greater equals to 1 and x lies between 1 by y to y. So we draw two lines. So the two lines are x equals to y. This is the x equals to y line, and another line that is x equals to 1 by y. So this shaded region actually gives us the non-zero definition region of this fxy, and we need to also ensure that y greater equals to 1, and we see that at y equals to 1 these two lines x equals to y and x equals to 1 by 1 intersect. So this is the one point, and above this region, this is the complete region where we can say this is non-zero definition region of fxy. So now question two was to find out the value of a, I guess. So we take integration of fxy, double integration of fxy from minus infinity to plus infinity, and as this is a value probability density function, this should be 1. So we put the value of fxy 1 by a into y square into x dx dy equals to 1. So first we integrate over x, and we get the integration of x equals to ln x from 1 by y to y, that is nothing but 2 into ln y. So we, as a is constant, we take a out of the integration, and so this part comes out of the equation 2 by a, and the integration limit is changed from y to 1 to y. Why is that so? Because as we can see, yeah, y is defined only greater equals to 1, so this limit is actually from 1 to infinity. So now we integrate over integration 1 to infinity ln y by y square dy. So we change the term. We assume that y equals to e power of w, and so ln y equals to w, and so dy equals to e power of w dw. We put these values and get that the integration is 2 by a into integration of 0 to infinity w into e power of minus w dw. So by doing integration by parts, we can get actually the value of the a, which turns out to be 2. Now the third question was, what was the third question? The third question was to find and draw the marginal density functions of fx and fy and verify that fx and fy are valid density functions or not. So how do we find the marginal density function fy? So we integrate actually from minus infinity to infinity fxy with respect to dx, and so the limit is changed from 1 by y to y, 1 by 2 into y square x, and after integrating we get that fy is defined as ln y by y square. So fy can be written in terms of fy can be written actually over two different intervals. So if y greater equals to 1, then it is ln y by y square, or it is 0 otherwise. So fx can be similarly find out minus infinity plus infinity fxy over dy. So the limit is actually from x to infinity, and we put the values. We take x out of the equation, and we get 1 by 2x if x greater than 1. Now for x, when x lies between 0 to 1, so fx actually it can be defined in terms of 1 by x to infinity, and similarly we get the value as 1 by half, 1 by 2, sorry, that is half. So over the range 0 to 1, fx actually remains constant half, and over the range when x greater than 2, it is actually 1 by 2x square. So this is the expression for fx. And if you look at the graphs, so fyy, the graph of fyy is like this, and the graph of fx, so it remains half when x is less than 1, and it is 1 by 2x square when it is x greater than 1. So this is the graphs for fx. And the final question was to verify that whether both of them were valid density functions or not. So we integrate from 1 to infinity ln y by y square, and doing integration by parts and changing the limits, we get that this is 1, so fyy is a valid density function. And for question 2 also, we integrate from minus infinity to plus infinity of fx. So uh, this can be actually separated into two parts. From 0 to 1, fx is half, and 1 to infinity, fx is 1 by 2x square. So we integrate and get that again the integration of minus infinity to plus infinity of fx is 1, which means fx is also a valid density function. So that's it for question 2.